हेलो फ्रेंड्स, अ वेरी गुड इवनिंग टू एवरीबॉडी। कैसे हैं प्यारे बच्चे? I hope everybody is getting the audio and video clearly. In today's class, we will be starting with the chapter States of Matter. Okay. Yeah. Okay. Kumud Bansal is also there today. Great. Samaksh is there. Nitya, Bhavel, Mithun. Okay. So we have got Mithun, Samaksh, Himank, Bhavel, Kumud, Nitya, Parul, Ravisha, Abhi, and Sakshi. Yeah. Bhavel says, sir, I am having some doubts. Most welcome, Bhavel. I am giving you the mic. May you please start with your doubts. Or rather, it would be better if you just write it down rather than speaking it out. It would be great if you just write down your doubts, whatever you are having. Whatever doubts you are having, better you can ask. Somebody else has joined us with this. Samaj Kumar, Nitya, Parul, Ravisha, Abhi, Sakshi, Manjol has also joined us. Okay. So I have to discuss questions from the objective worksheet. So dear friends, there are certain questions from the chapter Chemical Bonding, objective worksheet. Okay, the questions are, so we'll put this thing on hold, or rather let me take a new whiteboard. Here I'll be taking doubts of chemical equilibrium. Doubts of chemical, sorry, is it equilibrium? It should be bonding. Actually, I love this topic, chemical equilibrium. Okay, chemical bonding. So Bhavel is asking questions from objective worksheet. So the first question that he's asked is question number 6, 27, 6, 21, 27, and 40. Now question number 6 says, which of the following can exist as a dimer? So you see, when you're talking about dimer, the idea is that two molecules combine to form one. So see, AlCl3, yes. Now see, this chlorine makes a coordinate bond with the aluminium. And the aluminium is having empty d orbital, so it can easily accommodate these electrons. So this is a dimer of aluminium and is written as Al2Cl6. This is Al2Cl6. Okay. The next is BCl3. No, BCl3 doesn't form, but B2H6, yes, it forms a dimer. This is B2H6. Diborium. Okay. Ujjwal beta, right now I'm answering one question, so you can also understand when I'm writing something on the board, I will not be reading the chat, na beta. So let me finish with the question and I'll come on to your doubts. Don't worry. Okay. Give me some time. Let me answer the questions which have been asked first. Bhavil says page number 29. 29. Which 29? But what is there on page number 29? Okay, you're asking about page number 29, bonding 1. Oh, I thought you were talking about bonding 2. Bonding 1 is long back done. Okay, anyways, I solved the question for chemical bonding 2. This question might be of help to you. Let me just pick up chemical bonding 1. Okay, and this is on page number 29. Okay, and we're talking about objective worksheet. So it's given me question number 6, 21, 27 and 40, right? Right, Bhavil? These are the questions that you've given me? Okay. Now the first question is the non-metallic cation has. Question number 6. See, in OF2, oxygen has got a +2 state and it is oxyfluoride. Okay. So over here the cationic part is oxygen. Here. Similarly, you have got PCl3. Here the cationic part is phosphorus. And chromium is metal, vanadium is metal. Okay, so 6 is done. So these are the OF2 and PCl3 are the answers. The next is 21. Question number 21. In terms of polar character, which one of the following order is correct? See, beta, when they are talking about polar character, what is the best thing to do over here? You know, you should see the electronegativity difference. Electronegativity difference, okay? Fine. So if you can see, fluorine has got higher electronegativity difference, then oxygen, then nitrogen, and finally sulfur. Okay. So in the same fashion, you will be having the compound. So HO, HF is the highest one, that is in B and C, then H2. Yeah, B is the answer over here. Okay. Next is 27. The molecule which is having the highest bond energy. But a carbon and carbon bond is having high bond energy. This is one of the main reasons for catenation of carbon, if you remember. Okay, so this is having the highest bond energy. And moreover, please don't think over here that nitrogen forms a triple bond with nitrogen. He is not asking about the bond strength of nitrogen, nitrogen triple bond. He is comparing it with nitrogen, nitrogen single bond. Okay, so please do not get confused over here in 27th. Then question number 40. Okay, question number 40 says the stability of ions of will be in the order. See, thus when we are talking about say boron family or say carbon family like that, see boron can show +2 and +1 oxidation state. Carbon family can show +3 and +1, +4 and +2 oxidation state. Now, so you can see there is a higher oxidation state and there is a lower oxidation state over here. So higher and lower, I am writing HL, HL. Okay. Now when you are moving down the group from boron to thallium, the plus one state, the stability of plus one state increases, whereas the stability of plus three state decreases. Means the lower oxidation state, the stability of lower oxidation state would increase, the stability of higher oxidation state will decrease. And this I explained you, the inert pair effect. Okay. Same way when you move from carbon to lead, so the stability of plus two state is increasing down the group, and that of the plus four state decreases down the group. Right. So if you see over here, the plus two state is increasing. So this is choice A. And Pb2 plus, he's also saying, see, when plus 2 is greater than plus 4, so automatically Pb2 plus will be more stable as compared to Pb plus 4. So A and D both are correct, which means that question number 40, both A as well as D options are correct. Okay, so these are the doubts of Bhavil. Now let's move on to the next guy. One second. Okay. Now the next doubt is of Ujjwal. Ujjwal says, sir, videos of chemical bonding have uploaded up to back bonding only. I really don't think so. I don't think so. Till resonance they have been uploaded. Please check once again. Otherwise, you can contact Nitagya sir for this. Kumud has got the next doubt. He says, sir, what is the difference between minus 273 C and 0 degrees Celsius? Okay. See, Kumud, zero degrees Celsius is equal to 273 Kelvin. Okay. Excuse me. So when you say minus 273 degrees Celsius, you're talking about absolute zero, which is equal to 0 Kelvin. Okay. This was the doubt of Kumud. Next doubt is but I was asking, sir, why not F? F is more electronegative than oxygen, na beta? That is why. Acha, FF bond, because in the case of fluorine the size is very small. So what happens when a bond is formed between two fluorine atoms? They repel each other. Because of the repulsion, the bond strength goes weaker. Okay. Yeah. Any other doubt that anybody is having? Please ask. Any other doubt that you guys are having? Please ask. Hello, Prajit. Hello, Ayush. Ujjwal, Nitagya sir, I think it must have been given to you in the initial days only. Let me just check and we'll give it to you. Okay. I think if you are on the chemistry Flipland group, Nitya sir is there on that group as well. Okay. So you can talk to him on that group also. Okay. So let's start with a new chapter. So today we are going to talk about the chapter states of matter. See, primarily this talks about the gaseous state. Gaseous state. So the very first thing that we're going to discuss is gas laws. Okay, as you guys must have seen in the videos, I have started with the ideal gas equation part. That is PV is equal to nRT. And from here, see, at constant temperature, I will say PV is equal to constant. So this is the Boyle's law. At constant pressure, V by T is equal to nR by P. So this behaves as constant. So V is directly proportional to T, you can say like that. And here P is inversely proportional to V. Okay. And this one is Charles' law. Third is at constant volume. See, P by T is equal to nR by V. R is universal gas constant, right? So now this becomes constant because N is constant, R is constant, V is constant. So you get P directly proportional to T. And this is Gay-Lussac's law. Okay. And the fourth part is at constant temperature and pressure. We get V is proportional to N. And this is Avogadro's law. And here we talked about STP and NTP. And that 1 mole is equal to 22.4 liters. Okay. Fine. In the Charles law, we talked about the volume coefficient, which is equal to V naught plus 1 by 273 V naught. And here we talked about the pressure coefficient P naught plus 1 by 273 P naught. Okay. Now we have to solve certain numericals on these particular things. Okay. Huh. Okay. Now velocity coefficient. It's not velocity coefficient, it's volume coefficient. Kumar, it is volume coefficient. See, from here you can write V1 by T1 is equal to V2 by T2. Okay. So you can write this thing as V2 is equal to V1 into T2 by T1. Okay. Let us say you take V1 as V0 and T2 as T1 plus T by T1. So this will be V0 plus V0 T by T1. Okay. Now at T1 is equal to 273 Kelvin and T is equal to 1. You will be getting V0 plus 1 by 273 V0. I would like to tell all my students one thing, that this camera and audio is intentionally switched off by me. Right? There's no issues with any other thing. I do it when I feel like doing it. Okay. So I hope you must have been used to of it. Okay. Fine. Right. Okay. Fine. Yeah. Any other doubt? I'll come on to the diffusion part, Mahesh. Beta, give me some time. Give me some time. Okay. So now let us start with one question. I've got a very small question for you. See, what happened is, see, this is Sachin. Okay. I hope everybody knows Sachin Tendulkar. And this is Viru. I hope everybody knows who's Viru. Right. Now, what we have done is we have used a straw. A straw, with the help of a straw, we have connected the heads of Sachin and Viru. Now, in the head of Sachin, there is something called as a retirement gas. Okay. Now, we put a rubber band over here. Okay. Now, what happened? And now, the Viru's khopri, this is empty. And as per me, it was empty since birth. Now, the volume of Sachin's khopri is 100 ml. Okay. Now, please listen very carefully to me. When I removed this rubber band, the pressure fell down to 40% of initial value. %40 of initial value, right? The question is, what is the volume of Viru's khopri? I mean, what is the volume of Viru's head? I will say some master blaster. Yeah, but he's got retirement gas in his head. Yeah, Bhavel is very quick. And you know what? When you try to hit a quick shot, you get caught behind the wickets. And that's what has happened with you, Bhavel. Got caught behind the wickets. Take your time, solve it. Don't be in a hurry. Okay, so we have got 20 students in the class. Let me take the name of everybody. Starting with Bhavel, we have got Anag, we have got Abhi, we have got Aprajit, Abhi, Shivanshi, Nitagya, then Aryan, then Karan, then Ravisha. Okay. Mithun, Samaksh, Himang, Kumud, Mithya, Parul, Sakshi, and Sumit Sejwal. Yeah. Okay. Why only Bhavel is replying? Nobody else is replying back. Please check. And see, today I have got this book for you. I'd like to show you. So this is a good book as far as this chapter is concerned. So I'll try to pick up as many problems from this book as possible, because this chapter is more about law, numericals, as I told earlier in my videos also. Okay. Okay, Aprajit, wrong answer. Ayush, good. Bhavel, good. Very good. Yeah, what about Samaksh, Hemang, Kumud, Parul, Sakshi, Sumit, and then Jai Kishan, then Mahesh. Ayush has given me the answer. Aprajat, then Bhavil, then Anak, then Abhi, then Shivanshi, then Aryan, and Nitagya. Nitagya is he's a very good student. Nitagya is a very good student. Then Karan, then Ravisha. Yeah, why rest of you guys are not replying? Hemang has given the answer. Sumit, everybody is given the answer. Okay, fantastic. Okay, so the right answer is 150 ml. Now let me give you some good problems from here, this book. Okay. Fine. So now I need a bigger board, so I'm taking this particular form. Okay. And I'm writing down the question for you guys. Yeah, does anybody wants me to explain the answer for this question? Let me explain it. Even if you don't want, let me explain it. See, as temperature is not given over here, so we are assuming the temperature to be constant. So I'm saying P1 V1 is equal to P2 V2. Okay. Now see what happens when I remove this rubber band. The final volume will be the summation of the two volumes. So say initial volume is P1. The initial volume was 100. The final pressure is fell down to 40% of the initial value, which means it is 0.4 times of P1 into V2 is volume of Viru's Khopri plus the volume of Sachin's Khopri, which is 100. So you'll be getting 250 is equal to V Viru plus 100. So V Viru is equal to 150 ml. Okay, clear? Understood by everybody? I've got a hand raised over here by Abhi. Abhi, you have raised a hand. Tell me what is the doubt, beta? What is the issue that you are having, Abhi? Please tell me. Okay. At first you had some issue. Now there is no problem. Okay, fantastic. Now, so now I'm giving you the next problem. Okay. Now I'm writing the question over here. So see, there is an iron cylinder. This is an iron cylinder. Okay. Now it has got helium gas inside, and the pressure exerted by the helium gas is 250 kilopascal. Temperature is given to be 300 Kelvin. Now the cylinder, now the statement is the cylinder can withstand a pressure of 10⁻⁶ Pa. The room in which cylinder is placed catches fire. Okay, so this room catches fire. Now, if the melting point of cylinder is equal to 1800 Kelvin. The question is whether the cylinder will melt or not? Yeah, answer me. I hope the question is clear to everybody. Okay, Aryan says it will not melt. Bhavi says it will melt. Mahesh says, sir, what is melting point? 1800 Kelvin. Melting point is 1800 kelvins. ये फुल कर देना तो आप मुझे उसे हाई रहती है इससे इसलिए यदि ये छोटा हुआ तो वो दिखेगा वो तो अपनी सेटिंग ऐसी है ना वो पूरी प्रोफाइल दिखाता हूँ बात हो पानी ठहरे मुझे दिख नहीं रहा ये इसका मैसेज होता है ये तो उसने पर्सनली किया था ये सब दिखती है मिथुन अभी समाक्ष नित्या Ayush, Jai Kishan, Mahesh was asking. Now see, over here, what was the solution? The solution was, see, this is an iron cylinder. So here we are considering the volume to be constant. Okay. So what you had to do was, you had to apply the Gauss-Fix law. P1 by T1 is equal to P2 by T2. So P1 is given to be 250 kilopascal, which is 250 into 3 pascal. Initial temperature was given to be 300. The final pressure that it can withstand is 610 is to per 6. And then you have to find out the T2. So T2 would have come out to be 1200 Kelvin. Okay, fine. Now this is the temperature, the maximum temperature that the cylinder can withstand. So the cylinder will blow up before it melts. Okay, is this understood to everybody? Tell me, dear friends, is it understood? Okay, let us go with the next question. See, the question says that you have a vessel whose volume is V liter, pressure is 1 atmosphere, weight of gas 12 gram, and temperature is T degree Celsius. Okay. Now, so this is T1. The T2 is given to be T plus 10 degrees Celsius. Okay. Now he says when you increase the temperature by this, so this is P1, P2, I should give the statement only, that you do the calculation part. Huh? When you increase the temperature by 10 degrees, pressure increases by 10%. Okay. You have to calculate V and T. Molecular weight of gas is given to be 120 gram per mole. I hope the question is clear to everybody. Yeah, but Ayush, you are right. It will not melt. It will blow up before it melts. That means that it will not melt, beta. Yeah, it will blast. In the last problem, the cylinder would blast instead before it melts. Okay. Now solve this question. Ayush, the answer is not right, beta. Bhavil has given the right answer. Ayush sir, is anything constant in the question that you have to check? Ayush? Mahesh has got the right volume as well. Mithun has got the right temperature. Sakshi has got the right temperature value. Very good. Mithun, Sakshi both have got the right volumes. Nithya has got the right answer. Yes. Shall we go to the next problem, or anybody wants me to solve it? Tell me. Okay. Aryan Rastogi says, sir, please solve. Okay. See, Aryan, I hope you have seen the videos, and in the videos I've told you, when we are not very clear which particular for a law to be used, we should use the ideal gas equation applied at two different conditions. Okay. Now over here, this R is constant, and if you see the problem, the volume is also constant. Okay. So now P1 is 1 atmosphere. It says pressure increases by 10%, which means P2 becomes 1.1. Now number of mole N1. See, if you check the weight of the gas, it is remaining the same. When the weight of the gas is remaining the same, then the number of moles should also get cancelled. Okay. Okay, so it is P1 by P2 is equal to T1 by T2. What is T1? T degree Celsius. So T degree Celsius means T plus 273. What is T2? It says T plus 10, which is T plus 283. So basically you have to solve T over here. If you solve, you will get minus 173 degree Celsius, or you will get 100 Kelvin. Either of the ways. Temperature is 100 Kelvin. Now to get the volume, you will use V is equal to N1 R T1 by P1. So which is 12 by 120. R is 0.0821. P1 is 1 and the T1 is 100 Kelvin. So when you solve, we get 0.082 liter. Yeah, tell me, is this clear? Great. Okay, next problem. Now see what happens. I hope everybody must have seen this LPG cylinder in your life. This is LPG. Okay. You know, when it is empty, it weighs 14.8 kg. So I'm writing E for empty. Whereas when it is full, it weighs 29 kg. Okay. And when it is full, it shows a pressure of 2.5 atmosphere. So that's why you can understand why the gas comes out from the LPG to your stove. Now it was being used at a temperature of 27 degrees Celsius. That is a room temperature. Okay, while you were using it, the gas was moving out, moving out, moving out, moving out. Now, the weight reduced from 29 kg to 23.2 kg. Okay, now what you have to find out is volume of gas used and final pressure. Okay, and inside this LPG you have got butane. Butane is C4H10. Okay, yeah, but we are taking total to be 29, and this is JEE 1994 problem. This question belongs to JEE 94. Sir, is P2 1.6 atmosphere? P2 is let me just check. It's not 1.6, it is 1.5, Bhavil. I'm waiting for rest of the friends to solve it. Yes, Nitigya, have you solved it? Shall I solve it or you want some more time, dear friends? Jagishan says 2 minutes. Okay. We will take R as 8.314. Why? Why should you take R as 8.314, Samaksh? P is not 0.4. The volume is not 2240. Now tell me, shall I solve this problem? Okay, let me solve it out. This is a very nice problem, and I hope now everybody would appreciate why this question was asked in the ITJ exam. Yes, I hope you all are appreciating this part. Huh? Now see, the molar mass of butane is 58. Okay, fine. Now, what is the weight of butane in the cylinder? So 29 minus 14.8 is equal to 14.2 kg, which is equal to 14200 gram. Right? Agreed? Now PV is equal to nRT. N can be written as weight upon molar weight. Okay. Now what is the P? 2.5. Volume we have to find out. Weight is 14200. Molecular weight is 58. The value of R is 0.0821. Temperature is 300 Kelvin. When you solve it out, you get 2400 liters. Fine. Now in this question they ask the volume in meter cube. So anyways, if they ask it in the meter cube, it will be 2.4 meter. Even 2400 liters is also right. No issues with this part. Okay. Now this is the volume of the cylinder. Okay. Please remember, this is the volume of cylinder, which will remain constant always. Because the LPG cylinders don't, you can't compress a LPG cylinder like that. Okay. Now let's go to this part, this side. Now he says during the course of use, it was reduced to 23.2 kgs. Okay. So once again, I'm doing PV is equal to W by mRT. So now I have to find out the final pressure. Volume will remain 2400. Weight. Now you see, the weight was 23.2 kg. Okay. No, leave it. Okay, and when it is empty, it is 14.8 kg. So 23.2 minus 14.8, it comes out to be 8.4 kg. So this is 8400 by 58. R is 0.0821. Temperature remains the same. Okay, fine. So if you solve this out, the pressure comes out to be 1.5 atmosphere. Now I have done this question this way just to help you understand. Otherwise, you don't need to do this much. You simply see, I'm giving you an alternative approach. You would have simply done it this way. P1 V1 is equal to N1 R T1 by P2 V2 by N2 R T2. This is the alternative approach. Okay. What you would have done, volume of the cylinder would remain the same, R remains the same, temperature remains the same. As simple as that. So, what is P1? 2.5. P1 had to be calculated. What was the amount initially present? 14200 divided by 58. What is present now? 8400 divided by 58. So now you see the only calculation that you are left out is this. So this is P2, and from here you would have got P2 is equal to, from here you would have got P2 is equal to 1.5. Okay, see, this was the only simple calculation you had to do. Fine. Okay, now, so one thing was final pressure. Now it says volume of the gas which was being used. Okay, fine. So when you have to find out the volume of the gas used, how much gas has been used? 8.4 kg of the gas has been used. Now the point is, now I'm solving the third part. And see, it's very simple. PV is equal to W by MRT. So you see, this is step number 1 and this would have been the step number 2. When the gas is being escaping out, it escapes at a pressure of 1 atmosphere. Volume of the gas you have to find out. 8400. Now, what is the volume of the gas that has escaped out? You see, initially the gas was 29. Now the gas is 23.2. So how much has escaped out? 5.8 kg has escaped out. So you see, now you see how easy the problem was. It was 5800 by mass is 58. R is 0.0821. Temperature is 300. Okay. So this will come out to be approximately 2400 liters. So step number 1, step number 2, and you are through with this ITJE advanced level problem. Now tell me, now how many people would say, sir, this was tough? Yes, dear friends. Now tell me how many people are finding it tough? 2 simple steps. When the gas is escaping out, it should escape out at a pressure of 1 atmosphere, right? Because outside the pressure was 1. It was easy. Yes, it was easy. Beta, Mithun, you can take the value of R as 8.314 only when the pressure is given in Newton per meter square and the volume is in meter cube. So the change in mole into 22.4 is change in volume. No, not like that, beta. Aaron, you are getting it wrong. Volume of the cylinder is not changing. We have calculated the volume of the gas which has come out of the cylinder, considering the temperature is 300 Kelvin and the pressure is 1 atmosphere. Okay. Is it clear? Abhi is saying, so what you have done after that? See, very simple, Abhi. I see over here in the initial method, you have calculated the initial volume. Okay. Now you see R is same. Temperature, same. Okay. Volume 2400, which you have calculated over here, you have used over here. So basically the volume was same, the R was same, the temperature was same. So rather than doing these 2 steps, I have simply done the first step like this. There was no need of these 2 steps. You just can solve by this. But the pressure is 1.5 atmosphere. And secondly, the gas is escaping out at 1 atmosphere. The gas escaped is 5800 kg at a temperature of 300 Kelvin. So at a temperature of 300 Kelvin and a pressure of 1 atmosphere, the gas occupies how much volume? 2400 liters. Tell me, Abhi, is it clear now? Okay. So you like some more questions like this? Or you want the easy ones? Tell me. Easy ones are like this one. Okay, similar ones. Fine enough. Fine. Okay. So now let's see. Look at the next question. So there is a spherical balloon. Since I've got some shapes over here, let me use it. So I've got a balloon here, okay? And the dia of this balloon is 21 centimeter. Okay. We have to fill this up with hydrogen gas at NTP. Okay. Now, how will you fill it up? See, this balloon has to be filled up by this cylinder. Okay. It contains hydrogen gas and the pressure inside is 20 atmosphere. Okay. At a temperature of 27 degrees Celsius. Now see, this cylinder can hold 2.82 liter of water at NT. Okay. Calculate the number of balloons that can be filled up. See, in all the videos of this chapter, I have very categorically said, decipher the problem, decipher the problem. I hope now you people will be getting what I am trying to say. See, this question is all about deciphering the language, nothing more than that. Sir, am I supposed to fill the balloon with hydrogen or with water? Methane, please. Hydrogen. Pressure of balloon, it is already given NTP. RN says 6. No. 6 is very less. Sakshi says 10. Very good. Fantastic. Mahesh says 10. I think enough amount of time has been given. So those people who have not been able to solve it, let me solve it for you guys, okay? The answer 10 is right. Now see, let's look at the hints which are given over here. The first thing, since this cylinder can hold 2.8 liter of water, it means that the volume of this cylinder is 2.82 liters. Okay. Since you have to fill up this balloon at NTP, that is at 1 atmosphere. Now see, when the gas goes from here inside the balloon, the pressure over here will keep on decreasing, right? So the balloons can be filled up on, I mean, the whole of H2 will not go inside this particular balloon, these balloons, because when the pressure inside this container becomes 1 atmosphere, there will be no flow of gas from this container to the balloon. Okay, so the hydrogen will move out till its pressure drops to 1 atmosphere. This was the second hint of the question. Okay. Now see, now the question becomes very, very simple. What is the volume of one balloon? Okay, let me solve over here. Step 1. Volume of one balloon is 4 by 3 pi 21 by 2 whole cube. Right? So how much is the value coming out to be? 4.85 liters. Okay. Let us suppose we fill n balloon. Okay, so volume of H2 that is being used is 4.85 N. Agreed? Okay, now this cylinder, because the volume of this cylinder is 2.82 liter, so over here also you will be requiring 2.82 liters of hydrogen. So this is the total volume of hydrogen that you are having. 4.85 into N has gone inside the balloons and 2.82 is remaining in this cylinder. Agreed with this particular point? Tell me. Now this is the volume at NTP. Okay. Now you simply have to use P1 V1 by P2 V2 N1 R T1 by N2 R T2. Okay. Now see, R remains the same. So basically, see, the question is asking that how many balloons you can fill up. So this is the volume at NTP. Let us say the number of moles remains the same. The number of moles remains the same. See, though the volume will also remain the same, but because there is an unknown, so that is why I am writing the volume. So it will be, what is the initial pressure? 20 atmosphere. What is the initial volume? 2.82. What is the final pressure? 1. What is the final volume? Final volume is 4.85 N plus 2.82. This is equal to, what is the initial temperature that you have taken? Initial temperature is 300. Final temperature is 273 because it is in T. Now when you, so this is step number 1. This is step number 2. When you solve it out, N will come out to be 10. Tell me how many people have not understood this question. Bhavel is asking why 2.82. Bhavel, see beta, this is a cylinder, okay. Now from this cylinder, the gas is coming out into the balloons. Okay, so such N balloons you have filled up. But this will come out only when there is a pressure difference. When internal pressure is 1 atmosphere and external pressure is also 1 atmosphere, the gas will stop coming out. Okay, so at 1 atmosphere, you have got 2.82 liter of hydrogen inside this container and 4.85 into N number of balloons also you have filled up. So this is the final volume. So basically, what is the question saying? Now listen to me very, very carefully. The question says when the pressure goes down from 20 atmosphere to 1 atmosphere, temperature goes down from 300 to 273, what will be the change in the volume? This is what the question is asking, my dear friends. The whole story of balloon, cylinder, blah, 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 blah is just to confuse you. The simple story is initial pressure 20, final pressure 1, initial temperature 300, final temperature 273. So if initial volume is 2.82, what will be the final volume? That's what they want to know. That's it. So if you see what is the final volume is 48.5 plus 2.82 liter. This is the final volume. So if you would have deciphered it properly, then you would have said, oh my God, this is such an easy problem. But what happens is we get stuck with the language, and when we get stuck with the language, it's very, very hard for us to solve it. Right? समक्ष बेटा देखो, बहुत सीधी सी बात है. मैंने बोला ये आपके पास एक सिलेंडर है. इस सिलेंडर में हमारे पास 20 एटमॉस्फेयर पर 2.82 लीटर की गैस थी. अभी प्रेशर था 20 एटमॉस्फेयर. अभी क्या हुआ बेटा, इस सिलेंडर में से धीरे धीरे गैस हमने बाहर निकाली, तो ये प्रेशर कम होता जाएगा, कम होता जाएगा, कम होता जाएगा. कितना हो जाएगा प्रेशर? 1 हो जाएगा. जब अंदर प्रेशर 1 एटमॉस्फेयर हो जाएगा, बाहर प्रेशर 1 एटमॉस्फेयर हो जाएगा, तो क्या ये गैस बाहर जाएगी? आप बोलोगे सर नहीं जाएगी, तो गैस बाहर नहीं जा रही है ना। तो गैस कहाँ, कितना आप गैस को एक्सपेंड करा चुके हैं? आपने 4.85 लीटर के 10 बलून भर दिए और 2.82 लीटर यहां पर भी बचा हुआ है, तो ये फाइनल वॉल्यूम हो गई ना प्यारे बच्चे। बोलो समझ बेटा, अभी क्लियर हुआ? ओके ग्रेट, मजा आ रहा है सब लोगों को? एंजॉयिंग दीज प्रॉब्लम्स? हाँ चलो जी, आई थिंक आई हैव टू टेक अ न्यू बोर्ड नाउ, लेट मी सी इफ देयर इज सम स्पेस लेफ्ट हियर। Space. Okay. Now I'm going to talk about the Graham's law. Graham's law of diffusion and effusion. See, it says that R1 by R2 is equal to P1 by P2 under root of molecular mass of 2 by molecular mass of 1. And R is equal to number of moles escaped by temperature, sorry, time, volume escaped by time, distance traveled by time. Okay, or you can say the pressure drop by time. Okay, fine. Now see, we have to, now see, the formulas are very simple. It's all about deciphering the language, my dear friends. Okay. Now see, let's solve some question. So I am picking up the question of JEE 1999 first. The question says that we have got 1 mole of N2 gas. The pressure of N2 gas is 0.8 atmosphere. Okay. Now it takes 0.38 second to diffuse through a pinhole. Now there is 1 mole of a compound of xenon and fluorine. I don't know what is the formula of the compound. I'm not aware whether it is XCF2, XCF4, XCF6, whatever it is. I don't know. Okay, fine. All I know is that the molar mass of xenon is 131. Okay, the molar mass of xenon is 131. I hope all of you know the mass of fluorine. Okay. Now, this is at a pressure of 1.6 atmosphere. And this takes 50 seconds. Sorry, this is not 0.38. This is, wait a second. Sorry, I by mistake I wrote. This is 38 seconds, okay? Sorry, I by mistake wrote 0.38 seconds. Now this takes how much? 57 seconds. Okay, you have to calculate the formula of this compound. Sir, what is R? R is rate of diffusion or effusion, beta? Bhavil, the question is that 1 mole of nitrogen gas, which is at a pressure of 0.8 atmosphere, escapes through a pinhole in 38 seconds. Now there is 1 mole of unknown gas which contains xenon and fluorine. Its pressure is 1.6 atmosphere and it takes 57 seconds to escape. You have to find out the formula of the compound. Okay? Which side is crashing again and again? Which side is crashing again and again? See, the formula is written over here, my dear friends. Which side is crashing again and again? Please check. Please let me know. Yeah, Mithun has got the right answer. See, Aryan, I'll tell you. Let me repeat it for everybody, okay? According to Graham's law of diffusion or effusion, see, there is no difference between diffusion and effusion except one small thing. When something moves from high concentration towards a low concentration, we call it to be diffusion. Okay. But when this is happening through a pinhole, like the case of your, what do you say, deodorant sprays, right? Then it is termed as effusion. Okay. Now we have to compare the rate of diffusion or effusion of the two gases. The formula is R1 by R2, that is rate of effusion of the two gases, is equal to pressure of the two gases initially. This is the molar mass of gas 2, this is the molar mass of gas 1. Basically, rate is proportional to pressure and inversely proportional to vapor density. But as you know that vapor density is molar mass by 2, so this is inversely proportional to molecular rate. Okay. So rate can be number of moles escaped upon time taken, volume escaped by time taken, distance traveled by time taken, or pressure drop by time taken. So I gave you a question of ITJE 99. I said that nitrogen gas at a pressure of this much escapes in 38 seconds. There is another gas which is composed of xenon and fluorine at a pressure of 1.6 atmosphere escapes in 57 seconds. So the time is given to you. Okay. You have to find out the formula of this compound. Okay, this was the question. Mithan has given the right answer, but I'm waiting for others to provide the right answer for this question. Sakshi has also given. Fantastic, Sakshi. But yeah, you've also given. Very good, Sakshi. In fact, Sakshi gave it first. Very good, Sakshi. Beta. Sakshi, you belong to which city? You're from which city, Sakshi, and which school? Jagkishan, both the gases are effusing out under the same conditions, not from the same container, under the same conditions. DAV school, which city? Oh, very good. Yes, I think, two people have already given the answer, so I think rest all should also give it. Shall I solve this question? See, we will use number of moles of nitrogen by 38 upon number of moles of this unknown gas by 57 is equal to pressure of nitrogen upon the pressure of this unknown gas, molar mass of this unknown gas upon the molar mass of nitrogen, that is 28. So if you see, this is nothing but 1 by 38 upon 1 by 57, which is equal to 0.8 by 1.6 upon mg by 20. So when you solve this out, you will get mg approximately equal to 252. Okay, fine. Now in 252, you can have only one xenon, because if you take two xenons, it will be 262. So there is one xenon. So you subtract 131 from here. You'll be getting 121. Okay. So the formula that will come out will be XEF6. Okay, fine. Why we are subtracting? Because suppose if the formula were to be say 290, then I would have taken XC2, because then I would have subtracted 262, because that way we can find out the number of xenon in the compound. So over here there can be only one xenon in the compound. That is why I'm taking it like this. Is it clear? समझ बेटा, समझ में आई बात? भाई देखो टोटल मास 252 है. अभी उसमें से अगर एक xenon को देखोगे तो वो 131 है. अगर दो xenon होते तो 262 मास हो जाता ना बेटा. तो फिर तो फ्लोरीन बेचारा क्या करेगा? फ्लोरीन तो यूज ही नहीं कर पाओगे आप. तो आपको तो xenon और फ्लोरीन को मिला के कंपाउंड बनाना ना बेटा. तो इसीलिए हम लोगों ने क्या किया, 252 में से 131 हटा दिया. अभी जो बाकी मास बचा उसमें फ्लोरीन आएगा. अभी ये हमें पता होना चाहिए कि भाई xenon जो है वो XCF2 बनाता है, XCF4 बनाता है और XCF6 बनाता है. ठीक है ना, फाइन. तो वो जो अननोन गैस है वो XCF6 है. अब आप बोलोगे लेकिन सर परफेक्ट 6 तो नहीं आ रहा. बिल्कुल ठीक है, क्योंकि ये जो डाटा है ये कहता है कि इसका मतलब हो सकता है कुछ इंप्योरिटी भी रही होगी. So that is how it has to be understood. Is it clear? बोलो बेटा. JP Tejesh beta, I know that 121 by 19 is not 6. That's what I'm saying, na कि कुछ ना कुछ impurity होगी. There must have been some impurity, because XCF7 does not exist, XCF8 does not exist. Okay, so the best possible formula is XCF6. Okay, great. Now let's go to the next question. Okay. Okay, let's go to the next question. The next question says, let's see. Okay, we have got this rectangle. Okay. Now see, from here NH3 is entering, and from here HCl is entering. Okay, fine. The length of this tube is 200 centimeter. Okay. Now at some point we see white fumes of NH4Cl. We see some fumes of NH4Cl. Okay. So suppose if this is at a point P and this distance is x, what is x? Please calculate. Both the gases are entering at the same time at the same pressure. Both the gases are entering at the same time at the same pressure. Sir, can we expect any numerical engineering exam the data of which is in other temperature scales other than Kelvin and Celsius? Normally they don't ask beta. The language is already too difficult for you people to decipher. So that in itself is a big thing for you. Okay, if you are able to decipher the language, these are very small things of giving the temperature and all other things. Okay, solve it out. Mahesh, see the question is very simple. Mahesh, question says that there is a tube which is 200 centimeter long. From one side ammonia gas is entering and from other end the HCl gas is entering. And we see white fumes of ammonium chloride at a point P which is at a distance x from the HCl end. Considering the same pressure, same temperature, we have to calculate what is x. Okay. X is 70. No. 83. Yeah, you are close. 133. Bhavel, I think you're calculating it from the wrong side. Ayush wrong. Abhi wrong. Bhavel wrong. Aryan very close. Tejesh not exactly. Please do it once again. Okay, the answer is 81.1 centimeter. See, here you have to use the formula R of soil. Here you have to use the formula R of ammonia upon R of HCl is equal to square root of 36.5 by 70. Now here you would ask me, sir, why you are not taking pressure? Because pressure is given to be the same. Now distance traveled by ammonia will be 200 minus x. Time taken would be the same. Distance traveled by HCl would be x. Time taken would be the same. Okay, this is what we had to do. Now when we solve it out, the value of x comes out to be 81.1 centimeter. Okay. Okay. Okay, fine enough. I'll go with you. No issues. If it is 83.3, let it be so. Okay. Fine. Now, do you guys, I mean, no, Tejesh, that's your wish. You can take R1 to be HCl. It hardly matters. That's not a concern. Now tell me, are you guys ready for a bit of a tricky problem? Okay, great. I'm happy to see that all of you are pretty enthusiastic when it comes to tricky problems. Okay, so Praveen Kumar, give them a tough problem. So here you go, my friends. See, we are having, so this is a container, okay. Here the pressure was initially 2000 mm of Hg, and it dropped to 1500 mm of Hg. Okay. Time taken for this process was 47 minutes. Okay. Okay. Now, here basically there was oxygen gas, and this pressure drop was there because this oxygen leaked through a pinhole. Okay. Fine. Are you getting it? Let me repeat it. There is a bulb which contains oxygen gas. Its initial pressure was 200 mmHg. It dropped to 1500 mmHg in a time span of 47 minutes. Okay. Now what we did was, we now have evacuated the whole bulb. Now there is nothing inside. This is evacuated. We mean there is nothing. Okay. Fine. Now what we did was, in this container we have added oxygen plus there is unknown gas X whose molar weight is 79 gram per mole. Okay. Whose molar mass is 79 gram per mole. And these have been introduced in the ratio of 1:1, which means 1 mole of this and 1 mole of this has been added over here. They have been added till the total pressure over here becomes 4,000 mmHg. Okay. Now the gases were allowed to effuse out for a time span of 74 minutes. How much? 74 minutes. So I would like to know the number of mole of oxygen to the number of moles of this gas inside this container. See, initially we took 1:1 mole ratio. We allowed it to escape for 74 minutes. After that, I would like to know what is the mole ratio of these two gases. We have allowed the mixture to be escaped for 74 minutes. What would be the mole ratio after 74 minutes inside the container? Your time starts now. Okay, Abhi, the problem is we had this oxygen gas at a pressure of 200 mm of Hg. It was allowed to escape for a time of 47 minutes till the pressure dropped to 1500 mm Hg. After this container was evacuated. And now in this container, we are putting oxygen and some gas of molar mass 79 in a 1:1 molar ratio with an initial pressure of 4000 mmHg. Now the gas is allowed to escape, this mixture is allowed to escape for 74 minutes. After 74 minutes, what is the ratio of moles of oxygen and this X present in the mixture? That's what we have to find out. That hardly matters, Mithun, whether gas X is bromine or whatever. Do you guys want to take it for homework? Do you guys want to solve it as homework and get back to me on WhatsApp? Tell me. Do you people want to solve it on, solve at your home and share the answer with me? समक्ष मैं solve करूं, तुम try नहीं करना चाहते हो? अच्छा, how many people want me to solve it right now? How many people want that I may solve it right now? चले बेटा, let me solve it out. See, inside this container, initially the pressure of oxygen was 1500. Now the pressure is 1500. Okay. Now see, at constant temperature and number of moles, I may simply say P1 by P2 and volume, sorry, not number of moles, is equal to N1 by N2, right? So initially the pressure of oxygen was 2000, now it is 1500. Now initially the number of moles was N1, now it is N2. Let us say N1 was 1. So how much will be the value of N2? Tell me. N2 will be 3 by 4. Now what does it mean? It means the rate of escape of O2 is 1 minus 3 by 4 moles in a time span of 47 minutes, which is 1 by 4 into 1 by 47. Okay, this is the rate of diffusion of oxygen. Now see my friends, what is the cheating we have done over here? Here the total pressure is 4000 mmHg. But if you see, we have taken oxygen and X in the molar ratio of 1:1, which means over here also the partial pressure of oxygen is nothing but 2000. Over here also it was 2000. So it means that the same rate of diffusion of oxygen can be used in this case also. So rate of diffusion of the gas X by the rate of diffusion of O2 is equal to under root of 32 by 79. So that is number of moles of X escaped in the same time t upon what is the rate over here? The rate over here is 1 by 4 into 47 by time t. Right? This is the rate of oxygen multiplied by under root of 32 by 79. Now this t goes by this t. When you solve it out, you will be getting, sorry. The small mistake that I made over here, a small mistake that I made. Small mistake. Yeah. This is the rate. Okay, because we have already taken the time into account over here. So nx by 74 is equal to 1 by 4 into 47 is 160, 28, 188 into under root of 32 by 79. Now if you solve out, you will get number of moles of X is equal to, see, this would roughly come out to be somewhere around what, 0.249. Okay, fine. So now you can simply calculate it out that see, number of moles of X escaped is 1.249. So what will be the value of moles over here? 1 minus 0.249. And in the same amount, how much oxygen has escaped out from here? In the same time, how much oxygen would have escaped from here? The oxygen escaped, number of moles of O2 by 74 is equal to 1 by 188 So number of moles of O2 escaped from here would have been 74 by 188, which is equal to 0.39. Okay, so 394. Okay, so number of moles of oxygen remaining is 1 minus 0.394. So solve it out, you'll get the answer. Tell me, is this clear to everybody? Aryan is saying, sir, how come you can assume? See, Aryan, I'm not assuming it to be 1. My point is, whatever is the value, even if you take it to be x, it will be how much? 1/4 of x? It will be 1/4 of x. So the point is, whatever amount you take, in this time, 1/4 amount will escape out. Are you getting the point? So if in 47 minutes, 1/4 amount is escaping out, in 74 minutes, how much is escaping out? So 1.394 is escaping out. The point? Tell me. समक्ष बेटा देखो, let me just देखो, देखो बेटा, what is the, एक काम करते हैं, पहले ये निकालते हैं कि ऑक्सीजन का रेट ऑफ इफ्यूजन क्या है. तो देखो मैंने क्या बोला कि इन 47 मिनट्स, इन दिस 47 मिनट कितना गैस एस्केप हुआ. इनिशियली था 1 मोल, अभी बचा कितना है 3/4 मोल. तो गैस एस्केप कितना हुआ 1 माइनस 3/4. ओके, इतना एस्केप हुआ. फाइन, यानी कितना एस्केप हुआ 1/4 एस्केप हुआ. ये ऑक्सीजन का मोल है. हम किसका मोल है? ऑक्सीजन. तो हम लोगों ने बोला इन 47 मिनट ऑक्सीजन कितना एस्केप हुआ 1/4. तो 74 मिनट में ऑक्सीजन कितना एस्केप होगा? सो यू से 1/4 इंटू 74/47. देखो बेटा यही कैलकुलेशन आ रही है. 4 इंटू 47 इज 188 ना. तो आंसर कितना आया बेटा 0.394. This is the number of moles of oxygen escaped in a time of 74 minutes. अभी आप ये फॉर्मूला लगाओ, number of moles of X upon number of moles of O2 escaped in 74 minutes, escaped in 74 minutes is equal to under root of 32/79. 74 कैंसिल हो जाएगा. तो नंबर ऑफ मोल्स ऑफ एक्स कितना आ जाएगा? देखो 0.394 अंडर रूट ऑफ 32/79. ये 394 कहां से आया बेटा? देखो यहां से आया 74/4 इंटू, ये देखो 74 यहां पर आ जाएगा, 188 डिनोमिनेटर में, तो 74/188 कितना वैल्यू आएगा 0.394. 39/72, 39/70, 32/79 सॉरी. तो NX कितना आया बेटा 0.249 आया. अभी ठीक है समक्ष बेटा? बोलो समक्ष, इज इट क्लियर नाउ? तेजेश 4 into 47 is 188 बेटा. 4 into 47, this is 188. Tejesh 4 into 47 is 188. Now tell me, is it clear? I have WhatsApped the things to you guys. Okay? We go through this. If you got any doubts, we can discuss it in the next class also. Don't worry, beta. Okay? ठीक है? नहीं बेटा, व्हाई शुड आई टेक प्रेशर एज कांस्टेंट? प्रेशर का मुझे कुछ नहीं करना है समक्ष, प्रेशर का मुझे क्या करना है? ये जो 4000 mm प्रेशर है ये दोनों गैसेस का मिला करके था। सिर्फ ऑक्सीजन का कितना प्रेशर था? ऑक्सीजन का तो 2000 ही होगा ना बेटा। अभी क्लियर हुआ? ओके, चलिए, we'll do it in the next class. Okay, if you're not able to understand, we'll do it in the next class. Okay, चलो बेटा।